So in Unit 5, Lesson 2, we're moving on to something called radian measure. There's a great visual on the next page to describe what radian measure is, but let's talk about it first. Radian measure is when we unwrap the radius onto a circle. So if in your mind you can picture a circle, it's got a radius, and we're going to take that radius and lay it out on the circle. We sometimes refer to this angle measure as the distance around a circle's circumference after unwrapping the radius a certain amount of times. That's why it's called radian measure. Get it? Radius. Radian. And you're going to find out something cool about this formula that you've known since 6th grade. Since the distance around the circle is called the circumference, and the formula is c equals 2 pi r, that's the radius that's unwrapped to create a circumference of 2 pi? Well, let's just look at the video for a second here. Okay, so we have this little GeoGebra app that another math teacher has made, but it's really cool. Here is my radius, here in blue. So I told you a radian is what we get when we take the radius and lay it out on the circumference of the circle. So this blue line you're going to see is going to bleed onto the circumference. Ready? See how it's bleeding on? I'm going to stop right there. That's 1 radian. This blue was once a radius, and it looks to be about 57 degrees. Well, I know that it's about 57, but anyway, you can see it's about 60 is better. I'm going to take this red, and now I'm going to bleed that radius, or unwrap it, onto the circle. I'm going to stop. Boom. As it says down here, 2 rads, 2 radians. And now I'm going to bleed this green one on here. Boom. And let my brilliant people start to think. Wait a minute. I have 1, 2, 3, and a little more. What number is 3 and a little more? Oh my God, it's pi. 1, 2, 3.14. And if we remember, 2 pi was in that circumference. Well, 2 pi's would be 6.28. So there is 4 radians, 5 radians, that's 6 radians, and guess how much is left over? That's right, 0.28. So if I do that all the way, I know it's not going to show me, you can see it right there. It says 6.25, and just a little more will make it 6.28. And no matter what size circle I do that, so let's go down and make a little circle of 0.5. There we have it again. We can count out. 1, 2, 3, 4, 5, 6, and a little more. Yay, 6.28. So here it is that GeoGebra is again now on my smartboard. It doesn't work as well. I was having issues with it, so I just went right to a website and did it. But what we saw was that when we did have a unit of 1 for the radius, the circumference was 2 pi. And that's what we're going to be working with, something called a unit circle. And with a unit circle, the radius is always going to be 1. Because we just showed you that if I do take this radius and change it to something else, let's say I take this radius and change it down to 0.5, we're still going to get the same thing. We're still going to have 3.14 is going to be pi, and 6.28 is going to be 2 pi. So let's not make it hard on ourselves, but let's work with always a radius of 1. So we have a formula that you need to learn. And down here I have it written 3 different ways. It doesn't matter which way you learn. I tend to do this one. Radius times radian gets me arc measure. This is the same thing right here, just in R for radius. There's that Greek letter theta, which means radians, equals arc measure, or theta is arc measure divided by radius. So what does that all mean? Okay, so we just proved to you why the circumference is 2 pi r. Where is that going to help me? Why do we even need to know this? Because now we start to use angle measures, not just in degrees, but in radians. So when we want to talk how big an angle is, sometimes we don't say, oh, it's 40 degrees. We talk about its radian measure. In other words, we talk about this distance right here. Now that comes in very handy for such things as architecture and landscaping. Let's say you had to build a fence. You could figure out how much fencing you need without taking out some tape measure and rolling it out and trying to figure it out. You can just take an angle and convert it into radians, because the radians will actually give you the distance needed. And we're going to go into this more, but right now let's just get a little more familiar with radians. All right, so let's hit the highlights. We know we're always going to use a unit circle now. Get used to that word. Unit circle means the radius is always going to be 1. Because no matter what radius we use, we're going to get almost the same answers. Just have to multiply it by the radius. Again, I'm getting ahead of myself, so let's just talk about radians. We know that the circumference is 2 pi here when we're doing a unit circle with a radius of 1. So we used to say 90 degrees. Boom, there's 90 degrees. We no longer are going to say 90 degrees, but we're going to refer to that in radian measure. So what do we know? We know 90 degrees is half of 180. And we just learned from our lovely video that 180 is also the magic number 3.14. And then we learned that 3.14 is pi. So voila, that's how you say 90 degrees in radian language. It's half of pi. We know radian measure of 180 is pi. How about what's radian measure of 270 degrees? Well, 270 degrees means I went a full 180 and 90 more. So I went a full 180 plus 90 more. So that means I went 1.5 pi's. But we're going to see it as the improper fraction, 3 pi over 2. Radian measure of 360 is 2 pi. So I always remember this. Pi is 180 degrees, and then I see how far distance I went in relation to 180. So 45 degrees. Well, 45 is half of 90. Well, pi over 2 divided by 2. Oh, there's Mr. Allen looking in the back of my head. Double the denominator. So pi over 2 is pi over 4. And what about 30 degrees? Well, 30 degrees is 90 degrees divided by 3. So that's pi over 6. Now there is a formula which you can write down, and to take any degrees and convert them into radians, we multiply by pi over 180. And that's because we know pi and 180 are equal, so I'm not changing the wealth of this. So I could have done 30 times pi over 180. Cancel out the tens. 3 goes in there 6 times, 3 goes in there once, and oh my gosh, look what I got. Pi over 6. All right, so we want you to start looking at the unit circle as fractions of pi. So we want you to look at pi over 6 as 1/6 of pi. All right, so that means we want you to look at pi. Okay, so there's pi, there's 180, and we want you to divide it into 6 parts. Okay, if I divide that into 6 parts, let's see, that's 1, 2, 3, 4, 5, 6. Now I know I didn't draw that best, but you get the idea. And if I went 1/6 of the way, boom, that's the number pi over 6. Now we didn't ask you to turn it into degrees. We wanted you to understand that it's 1/6 of pi. How about 3 pi over 4? Well, we want you to look at that as 3/4 of pi. So once again, let's clean up our pi over here. I want to divide this into 4 parts. Okay, well, dividing into 4 parts is a lot easier. I can just take half and then half of each half. So 3/4 pi means here is 1/4, 2/4, 3/4. So it would be right about there. And again, we're not asking you to tell me how many degrees it is. It's 3/4 of pi. This one wants to be 1/3 of pi. Right, that means I'm going to take this and divide it into 3 parts. 1, 2, 3, and then obviously I want to go 1/3 of the way. So that's 1/3 of the way of pi. So when I get to something like 55 pi over 11, well, I can make that down into, reduce it, that's 5 pies. So if I traveled 5 pies, well, let's clean this up. And this is what I got. 55 pi over 11 is 5 pies. So here's 1, 2, 3, 4, 5. That's where 5 pies would be. All right, so we use the circumference of the circle to talk about distance around a circle. We learned that pi is really 180 degrees, which is 3.14 approximately. And it means how many radii you can lay out on a circumference. We also learned another formula. Radius times radians will give me my little section of arc length. And if you don't want to write that all out, you can do radius times radians equals arc length. Or you can just say to find a radian, I take my arc length and divide it by my radii.